Let's start then. Good day once again. Thank you for joining our webinar. My name is Arthur Bitsky. I work as an architect in Energy Log Server. Today I will describe our monitoring solution, Energy Monitor, that is a standalone product working side by side with Log Server, but can be deployed individually. Let's start. We'll have a short introduction through the presentation, and then a little time to work on the demo, live demo. If you have any questions, I will leave some minutes at the end. Please leave your questions on the chat. We will get back to this at the end. Energy Monitor comes from the idea of infrastructure monitoring. This is the application that allows you to take control over your whole infrastructure. The design is especially focused on the word whole infrastructure. We want to cover every device, every component, active component of your infrastructure, to see the status of its performance, possible errors, 24 hours a day, to control that in one place. The whole licensing concept and the design is meant to cover everything what is actively working and become crucial in your infrastructure. So in Energy Monitor, we would like to see all the servers, network devices, disk arrays, everything what is actively working in your rack, data center rack. We would like to control here, register and check whether performance of this device is working correctly, is good, actively working, and providing features that is designed to do. The project works with the Nagios Core engine, is compatible with that component, which means that if you've got knowledge coming from this open source project, you will feel very comfortable in Energy Monitor because it's fully compatible. It means that also all the services can be transferred from any install of Nagios. Also talking about the checks, the plugins that we can incorporate from community of Nagios into Energy Monitor. In Monitor, we would like to see everything. That's why we travel through the whole infrastructure. We during deployment, technicians need to put a list of everything what is active. We got very often the question, okay, what to monitor? And the simple answer is, if you don't know what to monitor, switch that off and you will see what is important or not. Everything is important at the end, and we want to see the status of every operating system, database, even tables in the database. What is the performance of your memory, of your network, disk arrays, along with external devices that are responsible for the power in your rack, the UPS, external sensors, temperature, humidity. We want to put that as checks in one place. What is a differentiator on the market for us? Energy Monitor works under control of Linux, which is, in our opinion, best place to adapt to customer environment. Very easily, we can extend features of control using scripts, using your existing applications to integrate it in Energy Monitor with control of Linux. Our focus is working at large scale. We don't see any limits in deployment of Energy Monitor. I will show you how the puzzle works. In general, we can build redundant setup. We can build high availability projects still with single user interface, single reporting interface. Only our probes share the load and provide high availability in the whole Energy Monitor setup. System is delivered with bunch of checks, huge library of those control methods, very easy to extend. We can write own checks, copy existing, change, and put it back into working environment of Energy Monitor. Unique on the market is our support. We do not want to limit any tickets, any phone calls. We want to support your projects at 100%. That's why it is unlimited. We will help you not only with the application of and possible bugs or errors, but we'll help you how to create monitoring. What is the best approach in control your environment? Do we have checks for that component? And you can always ask question what to do in order to cover control of specific device or application. Once you log in, the subject of monitoring is a host, object connected with your IP address. On the left-hand side, we see the list of devices. At the right, all the statuses in 3 colors, green, yellow, and red. Very clearly tells you what is the status of the device, what needs to be checked, what is wrong. Quick overview of what is happening actually in your environment. Every check is scheduled every 5 minutes automatically, and it's independent from others. Having Linux as a base operating system, we are 100% sure what do we check, what kind of metrics we deliver to monitor, and what is the information sent to network operating center. Technically speaking, once we dive into the methods, we would like to use agent approach for operating system, where we can control all operating systems on the market, together with the ability to enlarge features, to add new checks. It's very easy to do this on your own or with help of our support. Working with databases, we use client approach, no agent, but we use simple SQL queries. Already, you can see that checks are available in Monitor using that queries, but it's very easy to write your own query, to query your application table, to see some specific method that you would like to control specific to your environment or your application. Once we move towards network visibility, we read all the SNMP data. It's perfect approach for equipment that is delivered as a box. Vendors put this protocol for years, and it's the most convenient way to control performance of interface, of status of your power supplies, of temperature of the device. All checks are performed through SNMP. I said that we can also integrate monitoring with some infrastructure control devices like flat sensor. door opening sensor, but also power supplies, power generators, printers. This is a way where we enlarge view of typical infrastructure approach with all the external devices that need to work to deliver the service. Talking about the service, Monitor is equipped with a bunch of checks dedicated to individual application. So we initiate a connection using a protocol like DNS. We work as a DNS client. We ask a specific record. We would like to check whether the record is resolved in that specific way. Everything is provided with attributes, so we know what to ask and what is the answer. Once we put that in a loop, we control it every 5 minutes. We have 100% guarantee that our DNS service is exactly working in a way it should. And the last point, with Energy Monitor, we can track the whole process, how the web application is working. We can simulate the steps that the user performs. We can log in, we can check the result, we can query, we can jump through tabs and see performance of each and the content, how long the page is loaded and whether it's containing the data it should. Large-scale approach is crucial for Energy Monitor because the number of systems that we see that our customer grows. That's why very often we start the project with single instance. We call it a master, which is technically not limited, but the performance will end up at a certain moment. We try to check whether the moment for building a larger system could be at a level of 500 devices. It's not hard limit, but if you have more, it depends on the hardware, whether you can still use single instance or you should share your load into separate components. And these are Monitor Peer, which is working as a cluster to your master instance, but also can work along with a probe. We call it a poller. You can put that probe into different division, into different data center. It performs all the checks like the master instance, but work locally, buffers the data, control, and push result to master instance. You can see that on this sample project where we have a master instance. If the master instance need to be put in high availability mode, we add second redundant setup peer. And below we have a selection of pollers, our probes that control maybe your second division, your second city, different location. Still, the poller can be not enough, a single poller to control environment. And then it's possible to also make a local cluster at that location, having poller working together with peer. Most important is a way how we work with the data. From user perspective, your network operating center guys, they are still working with the same system. There is no difference how big the deployment is, what is the puzzle underneath. The way you work with the monitoring is exactly the same. Sometimes it's even hard to tell what is the setup because it's under full control of integrated components, as you see here. In Monitor, you can create your dashboards, your graphs. That graph can be put in a loop. Again, very often we see in network operating center that the graphs are loading one after another to give you quick overview what is status of your core application, of your core network segment. It depends what you want to show. Going into details, every host is controlled with number of services. We will see that on the demo. So I will move forward on this slide. Typically, a single IP address is containing 10 to 30 checks, additional checks for individual methods connected with the device. Important part is the baseline for each check. We store results of every service. We keep raw data. We do not we don't cut them. For the whole history we keep all the records and allow user to query to see the results at the moment of failure, but also to analyze it from the historical perspective, combine it together with other checks to see what was the reason, because the actual problem could start some days ago. That's why we need to keep a record of every checks, and this is stored in a NoSQL database designed especially for time series data. That's why we are able to keep raw original data without any loss to the information. Another example how graphs are created. Details of individual machine, of individual servers, what is the number of checks, what was the performance, how long the check took, what was the last check. So we see all the data and details here. Business process intelligence is another component of the system. A short introduction why we introduced that. Component is responsible for building a complex check for your core application. If you imagine your ERP system or CRM or a service called corporate email, these are not simple checks because the number of devices and systems that are working together to create that service, like your internet connection or corporate email, the number could be huge. We need power supply, we need routers, we need internet signal, DNS, the server itself, and the puzzle is made through the logic because we have some clusters, redundant setups, we have groups. So business very often asks for the report representing the service, not the individual component, not how the UPS performed, but did we provide internet access to our users? Business process intelligence allows you to create a logical connection between elements that we already have in the system. Every check can be put here as a puzzle connected with logical junction. We can create groups. We can escalate, provide prioritized groups. At the end, to see single status of the whole application being seen from the business perspective. A dashboard example, every user can create own dashboard. We can exchange dashboards between users. We have private, public dashboards. Those components can be adjusted to individuals. Once you discover a need that a system needs another component, another check, another service, or you bought new device and would like to cover monitoring for the device, it's very good to check what the community has already done in the topic. Again, our compatibility with Nagios Core helps. First, we need to check whether this open source is giving you the answer. It's easier to take that example, rewrite the code, integrate into Monitor, than to start from scratch. These are numbers of already available checks through the open source community. Every check can create alerts and notifications. We send emails, SMSs, traps, syslog messages. We do external integrations. We can automate operation as a handler for that problem. At the end, we can escalate the problem. We can inform the manager that the problem still exists in the infrastructure and the escalation is in place. I haven't mentioned logs. As you know, for logs, we do have Energy Log Server, but it makes sense to see logs and infrastructure checks at one place. That's why in Monitor, we can see dashboards from Log Server because the applications work in the close integration. We can also query data through external check to see whether Log Server is containing crucial information based on logs. Put that as a query into Monitor and check the threshold whether we are receiving hits for that query. And at the end, the licensing approach, we can provide perpetual license, which is quite unique on the market. It's a regular license with optional support. Of course, 1 year and more subscription-based license. And the MSSP program is also available. That means that the license is based on number of devices under control. And this is the most important component when we talk about the price of the system, the license. High availability components are also licensed. We calculate them as a 50% of the basic license. And that's simple, that's it. There are no more limits. You can put number of services as you wish. And important information that's up to 50 monitoring devices, you can get Energy Monitor for free. Right, let's try to see how the application performs. I will use our demo, hope that everything works fine. It's a live system, so anything can happen. We can select mode, dark light, or custom. This is available. Here in that place, we have our dashboard built from components. Every user can adjust and build own view to control a specific segment of the environment or the whole infrastructure. That's why we can create that view built from components like widgets that represent status of services or a host. Very often our monitoring is started from the host overview, where we see our devices on the left-hand side and the major status of it, one by one. If we would like to group them, it's also possible. We can group hosts to create network groups, Windows groups, Linux, and share, for example, visibility for departments, for users in the organization. If you would like to see individual checks for that host, simply select service view, and we are able to browse every component. In that example, we have 26 checks for that machine. We control not only typical status of memory, disk usage, but also we can add mount point monitoring, a queue for mails, it's our mail server, services, processes, even if the system needs an update or not. If you want to query something specific, we can use the search. It looks for anything that contains the word ping, could be host, could be service, and we see all the results in one place. Here on the demo, you can see that we not only control operating system, but we want also add visibility for virtual hypervisors, could be VMware, could be in that lab, we have also Proxmox machines. Then we see performance of each, how the CPU is working, network devices, general status of services, of storage, disk subsystems. So at one place, it's quite detailed approach, but it ends with not more than 30 checks, which is not a large number. So we try to focus on pieces of information that we really need, but we do not create a traffic of the stream of metrics that no one analyzed at the end. This is empty. We try to see some graphs. Okay. Once the device is providing some metrics like availability in ping or status times, some disk capacity, then as I mentioned on the presentation, we keep a record in integrated NoSQL database. That's why we see the results here. We can see the performance. In that example, we got only one peak, but the difference for monitor is that in that application, you see everything one-to-one as we receive the answer from the host. We do not average. If you would like to see average value, you can have it. But in first query, we provide original data. Every graph can be put into reporting section. In the reports, you are able to create availability report based on your services, your host, or entire groups. Quick select and details of the report. What is the reporting period? How to calculate states. There are technical details. I will not jump into this today. If we would like to see not only percentage in a table of availability, but also the graphs of performance to send it to our manager in a PDF format, then we need to flag that option. Could be as a summary. First section of the report contains status of selected components for the selected time period. And the graphs itself are also presented one by one after another. That report can be scheduled and delivered in an email attachment in PDF. Important part is a way availability is calculated, because the system typically performs checks every 5 minutes, 7 days a week, all time. It does not mean that we need to report our service in entire time. We can report availability only in working hours. However, we still monitor service during the night. Even more, we have downtimes in the system. We can plan our scheduled service works. Downtimes are available from the top menu. Once the system is in the downtime, when we create a report, we can decide how to calculate downtimes, whether the system should be should present a real availability or only calculate time skipping downtimes. Configuration page. From that section, we create a new host. We can perform a network scan. We manage our notifications. We provide details about emails and SMS gateways. Here in comments, we can check what is already provided as a method of control in the system, what kind of command is scheduled. For each, we provide help. Also in configuration page, you can build your strategy for role-based access control. Everything what you see in the application can be divided into some roles with individual access. On the left-hand side, we see our roles and what object can it access. For example, we've got service groups. Can we add a service group or delete? Can we view very, very granular permissions at every level, along with access to API. API is giving you the way to control the whole system through integrations. We can control host, we can add services, modify through development and integration available through API. But still, you need to have access to that feature. Your user can work locally, but very often we can add a module for your Active Directory integration, Radius. We integrate with groups from external systems. And finally, business process intelligence is a place where you can create something like a master group, your service group, putting components of individual checks, creating one or more group for each. We set up a warning and critical threshold, how many components need to be available to see a green light at the top level. The strategy here is that once we build business intelligence components, we can deploy them to a service and create work with them as they were regular checks for the system. Then we can put it on the map. We can use it on the dashboard. We have a dashboard component for business intelligence here. On that view, we are waiting for integration with log server. I haven't checked it before the presentation. It is external integration, so something is here querying the data for a longer time. Your Windows machine. We got as well some printers. So you see, we want to keep an eye on every active component without any limits. The approach here is to see the status every morning, how the infrastructure performs, and are we expecting problems that day, or we can continue with our regular tasks. I hope you got an overview how the application performs, how we work with hosts and services, how we can create that monitoring. I will jump to questions. I see some questions on the chat. Let me cover this. Are we going to implement AI capabilities in Monitor? Thank you for that question. Of course, yes. The reason of if someone recognizes components of the application, it's not a surprise that Monitor is built from projects that are partly available in open source. But very quickly, we exchanged the components to something better, like the graphs. Today, we are able to store every value in NoSQL database, exactly the same database like we do have in log server. And of course, AI will be here working for calculating dynamic thresholds. That is first bullet on our roadmap. And also, we want to train models to see how the infrastructure will perform in 2-week time, for example, to predict possible problems with help of mathematical algorithms. So definitely that will be a part of a monitor. The strategy here is that monitor will always be a separate offering. Having said that, AI will be a component of monitor. You will not need log server to analyze data of monitor. That component will be here available. What will come in the newest version of monitor? Today, when you create a host, you put details into this section, and also you need to know what kind of checks you would like to have. You can copy checks from already working examples. For example, yeah, I would take that one. Something here in edit section of a service, you have an option to clone the one or other services into new host. It's designed today to help you having the same approach from single host to the others. In new version, you will be able to do this once the system is added. We will automatically recognize number of hard drives in the system, network interfaces, your cores, and multiply checks through this to automatically scan and schedule scan to cover the problem that the infrastructure can change. Someone can add the disk, and we would like to see the change once it's added. So that will that automatic scanning will come in the upcoming version. How the license? How do we license? So once again, we take a look on the number of hosts. I will jump again to this section. In my demo, we have 34 monitoring devices, and as I said, 50 is for free, and then we have 100 host steps. So this is the subject of the license. How many hosts do we want to monitor? 100, 500. We suppose system with several thousand of hosts that will end up with 80,000 services, but they are not limited. So we only keep an eye on number of hosts and the question, do we have a redundant setup or not? But the hosts are the crucial information for licensing. We don't calculate logs, we don't calculate events here because we control environment, so the host is crucial. Question about the MSSP model and the ability to divide the view into tenants. Yes, you can do this. once I showed you the group rights, you can connect a single group to number of hosts, especially your host group. Your host group will become a tenant, and users belonging to that group will see only that infrastructure. Application automatically scales down, limits the view to the devices that you selected, and that will, from the user perspective, it will be limited only to own organization. From administrative perspective, that will be same install with all the services and hosts working at one place. Another question: if you have 100,000 in the main site and 100,000 in the DR, how many licenses we need? If we monitor 100 devices, you need master 100 and the peer 100. The peer will cost half the price of main license. What I want to show you here, in fact, we have distributed setup. We have our main install and another probe working remotely in different city. I haven't mentioned it before because, as I told you during the presentation, it does not change anything. It's just a way monitor works, which means that if we select a service, let's take the HTTP check. Here, we can schedule our check. If we have a redundant setup or distributed setup with a number of components, we can decide from which point that check will be initiated, or will that be from that server or from our probe. This is not configured. This check is aimed to work only on the main machine. So from administrative perspective, it is still one system, only the checks are traveling where they should. It's very easy to set up because we decide what is being controlled through which server. We need to we create a host group. Once we add a host to a host group, probe connected, responsible for that infrastructure will perform all the checks once you save the data. So this is example of our probe in different city. We've got 2 hosts there, as an example, 2 Proxys machines, and they are actually checked from the remote system. You see no difference in Outlook. We have exactly the same view, no matter how they are monitored, but the results are coming from the probe. Granularity. Default is 5 minutes. You can easily set up that interval into, default is 5 minutes, and you can set up to a single minute. You are not allowed to go below a minute because the minute is a base. If you decide to have a check every minute, you are free to go, no problems at all. Some checks, we can decide whether they should work more often or deliver quicker answers, so no problems at all. Standard is a base is a minute, so you decide single minute or 5 minutes by default. Up to you. Thank you very much then. I invite you to get hands-on, get a free install for 50 devices. Send us questions. We will try to help. And we are here available whenever you need. Thank you very much. Good day. Bye.